Welcome to the next video of the third section, Tkinter and Threading. In the previous video, we've learned how to play the drum machine. In this video, we'll learn about Tkinter and Threading. One of the simplest ways that we can make our root window responsive is to use the root.update method within our play_pattern loop. This updates the root.mainLoop method after each sound sample is played. However, this is an inelegant method because the control is passed to the main loop with some staggering experience in the GUI. Thus, you may experience a slight delay in the responses of other widgets in the top level. Further, if some other event causes the method to be called, it could result in a nested event loop. A better solution would be to run the play_pattern method from a separate thread. Let us use the threading module of Python to play the pattern in a separate thread. This way, Pygame will not interfere with Tkinter's main loop. A thread is a coding construct that can advance two or more separate sets of logical workflow together within an instance of a running program process, context switching between the workflows. Each thread in a running program gets its own stack and its own program counter, but all threads in a process share the same memory. In contrast to threads, processes are independent execution instances of programs, each maintaining its own state information and address space. Processes can only interact with other processes using inter-process communication mechanisms. Threading is a topic for a book in itself. However, we will not get into the details and instead use the threading module from the Python standard library. The threading module provides a higher-level threading interface to hide away the inner complexities of implementing a multi-threaded program. To use the module, let's first import the threading module into our namespace. Now let us create a method, play_in_thread, by using this highlighted code. Finally, change the start_play method to call the play_in thread rather than calling the play_pattern directly. Now, if you load some drum samples, define the beat patterns and hit the play button, the sound will play in a separate thread without causing other widgets to become unresponsive. However, this poses a new problem. What happens if the user clicks the play button multiple times? That would spawn multiple threads of beat patterns all playing simultaneously. We can overcome this problem by disabling the play button when the audio is playing. This can be achieved by defining a toggle_play_button_state. We then attach this state toggling method onto the play, stop, and loop widget command callbacks as. We also modify our play_pattern method to include a call to toggle_play_button_state at the end. This will ensure that when the pattern has ended playing, the play button returns to its normal state. The play button now remains in a disabled state as long as some audio is playing. It returns to a normal state when audio isn't playing. Tkinter and thread safety. Tkinter is not thread safe. The Tkinter interpreter is valid only in the thread that runs the main loop. Any call to widgets must ideally be done from the thread that created the main loop. Invoking widget-specific commands from other threads is possible, but it is not reliable. When you call a widget from another thread, the events get queued from the interpreter thread, which executes the command and passes the result back to the calling thread. If the main loop is running but not processing events, it sometimes results in unpredictable exceptions. In fact, if you find yourself calling a widget from a thread other than the main loop, chances are you have not separated the visual elements from the underlying data structure. You are possibly doing it wrong. Before we complete this iteration, let's take care of a small detail. What happens if a beat is currently playing and the user hits the close button on the window? The main loop will die and our audio playing thread will be left in an orphaned state. This can lead to ugly error messages thrown at the user. Let us therefore override the close button and stop the audio play before we quit the window. To override the close button, we add a small line to our class, _init method, as highlighted here. And then we define a method called exit_app like this code. This completes the project iteration. To summarize, we refined our start_play method to play the audio files on a separate thread. We also made sure to disable the play button as long as the audio plays. Finally, we overrode the close button to handle exiting when some audio is currently playing. We used Python's built-in threading module to play the loops in a separate thread. We also looked at some of the threading-related limitations of Tkinter. However, threading is a vast topic in itself, and we've just scratched the surface here. You can find more details about the threading module at this site. Great! We've successfully learned about Tkinter and threading. In the next video, we'll learn about support for multiple beat patterns.